Well, we're back. Hello, Aaron. I have one question for you today. Are you my mother? I think that was from our last episode. It ended up being turned into. I was turned into some memes back at the office. I don't know if everybody got that reference from me.
You're meme worthy.
Yeah,
I think there's a few memes about you floating around on the internet.
There are. Not everybody got the Dr. Seuss reference that came from. So, anywho, hey, welcome back.
Thanks.
You and I both spent some time in a warm location, which caused us to not be able to do our show. We prioritized,
that's my preference.
Yeah, prioritize warm weather and that kind of thing. But here we are again, continuing on our discussion of basics that started around the new year. And it's the gift that just keeps on giving. But we're going through the CIS, core basic implementation group 1. Controls, the basics.
That's what you meant by vulnerabilities. I thought you meant like my childhood trauma. Oh, I've come prepared for the wrong topic today.
To kick back on the couch and and be vulnerable.
Yeah. Okay. Yeah. Well, I'll adjust on the fly here.
Okay. Well, that's the plan for today. So here we go. Well, let's launch into it.
Okay.
Okay, so we're talking about the basics today of vulnerability management, and this to me is it boils down to patch your stuff. I think if we had a super basic version of vulnerability management, how would you define? I always kick back and tell Brian stories, but how do you think about vulnerability management other than starting with patch your stuff?
Well, I don't think you can start with patch your stuff. I think that maybe vulnerability management sort of ends with patch your stuff. I think it begins with identifying what you have, which we talked about last time.
Right.
But then once you know what you have to know what vulnerabilities apply to it. So I think it's vulnerability management's a 2-step process.
Right.
Find a vulnerability and then patch it.
Correct. And it, probably builds on our first 2 topics. And we said inventory of hardware, inventory of software, that even amongst the implementation group 1, you almost go in priority order. If you don't know what hardware and software you have, it's going to, that at a minimum makes it hard. Can't patch things you don't know you have, basically. And even to have some sense of, well, what's my, begs the question, patch my stuff. Well, what stuff is that? What is my stuff? And kind of goes beyond that. And I had a screen to share, but it's not coming up. Oh, there it is. Change this a little bit. Patch your stuff. SANS and their fantastic way. As you kind of said, there's a little more to it. They've got this model, the PiAct model, prepare. So, policies and standards and context. Well, context getting to, I think, well, what stuff do you mean by patch your stuff? A lot of people, we can talk about this a little bit, but a lot of people like operating system. If I patch anything, maybe I'm pretty good at operating systems. And maybe if I start with one thing, a lot of people, their patch management process or vulnerability management process is like, yeah, Microsoft patches come out on Patch Tuesday once a month. And I go ahead and pretty much apply those. And that's my vulnerability management. But context, what else to do? And then identify, what do I do automated? What do I apply manually? External things I got to deal with. I'm not going to read this whole slide, but they kind of.
I appreciate, our viewers appreciate that.
Yeah. But they kind of add to it of, you have this cycle of things you have to do, pre-work, identify which patches, prioritize, analyze and prioritize. Okay, which ones are most important? Can I wait a month to do this? Do I have to do it tomorrow? Do I have to drop everything and go frantically apply patches tonight and take systems all offline? Communicating, people impacted, my metrics, how I'm doing, and then treat. This is the actual patch your stuff phase of okay, go apply those, basically.
This feels like a very academic approach to vuln management. How much do you think this lines up with reality for people?
I don't. I mean, I think it goes back to, there is that patcho stuff, or maybe we use another word for stuff. It's kind of a cliche, and I've heard it as a cliche in security people who've never had to apply the patches themselves, or they apply patches to their Windows computer at home and they think, well, just apply that to the enterprise. And it's often said, like, I don't know why this is so hard for the fill in the blank team, the database team, the network team. Just go patch your stuff. Like, it's not hard, just do it. And there's truth and fallacy to it. But in implementation, kind of like I said, my experience is most people, it's like, yeah, because I've gotten, if I run infrastructure, if I run IT at a company, I've gotten pretty good at that Microsoft patching cycle, because it just goes on and on. Every Microsoft Patch Tuesday, I've got a set I need to apply, and I just have to figure out how to apply them. And then I find, both in my own experience and the number of companies I talk to, you kind of get out beyond that of, well, okay, even something as basic of what about PDF readers? What about the zip unzip programs you use? What about Java versions? That's the ugly, very few people, from what I've seen, have their hands on that.
Yeah, it's because they have 6 different versions of JVM installed.
Yeah. Well, and I think what it amounts to is that vulnerability management is a best effort program for a lot of people, saying,
where does ignorance is bliss fits in here? Where's that in the step of just don't look and then you don't have to patch it?
Well, and a lot of people, and I think there are industries that are highly regulated where somebody somewhere occasionally pays attention and you have to demonstrate the due diligence. And then if you're, let's say, a manufacturing industry, that, especially if you don't do work for the Department of Defense, maybe even if you do work for the Department of Defense, but where it's just like, I don't know, I got stuff out on the manufacturing floor that, plugs it. But, as I think we've said before, that Hitachi manufacturing robot came with, 2 years ago with Windows XP embedded in it.
Sure.
And,
There are no patches for it anymore.
Patch
But
what?
yeah.
Or in healthcare, IT tends to be has to be, very should be very buttoned up. But then you get into like uh, clinical engineering, biomedical devices, an MRI machine, a infusion pump that also have operating systems in it, and you have this. Your mileage may vary. I mean, people say, well, it's an FDA regulated. I don't know that I can patch it. I don't know. There's a human being hooked up to this thing, and I'd prefer that it's not vulnerable to stuff, but I'd also prefer that it doesn't go offline unexpectedly, or, I don't know what that patch is going to do to it. And so, again, mileage varies. I have not run into a lot of organizations that have, as much as it's a basic, have it really buttoned up. I think people are getting to the turn on automatic updates, or, kind of whatever enterprise system equivalent of that, of they're applying a lot of people, maybe not even the majority, but a lot of people are applying automatic updates.
I think it depends on whether that you're talking about a legacy workload in somebody's own data center or something that's running in the cloud.
Yeah.
And especially if it's cloud native, because those are two vastly different worlds.
That's a good point too.
And this is one of the things I see with, when you look at calculating the total cost of ownership of running in the cloud, and people are like, see, it's cheaper if we do it ourselves. And then they just neglect all this stuff.
Right.
And it's like, well, of course, doing nothing is always cheaper than doing something. But there's a lot of benefit to the automation that we do, especially when we use a microservices model with APIs, and like it solves a lot of these problems that you have here when you're talking about traditional like legacy 3-tier applications and how hard it is to keep up with the patching.
Yeah, that's a great point. I mean, your average, your typical platform as a service vendor in the cloud. So here, think your Salesforces of the world, your hosted Oracle, your Amazon hosted databases, and not like I'm going to set up an server instance in the cloud and build up my own.
I don't mean virtual machines.
Yeah. Like I'm using their, shared.
Well, I can tell you, Brian, I almost never patch my Gmail server.
Yeah, right. Exactly. Gmail is a great example. Zoom, or whatever where, and I have lived in that world, and it's always very interesting of, that your workload, you're not patching, but you do, if you have things that are integrated, that no, I don't want to take that patch because I'm not ready to do integration testing and make sure it works. Like, just not really an option in
which is probably, I think in my book, that's a good thing.
Absolutely.
It's not an option is good.
Yeah, no, I would tend to agree. So yeah, very much this applies.
Well, and we as a society are so bad at it that I want to say it was 40,000 that the Department of Justice approved a search warrant for the FBI to log in remotely to 40,000 Exchange servers and force the patches applied to them because they're causing so many issues. And there are probably 40,000, it would appear, organizations out there that had their Exchange server patched, and who knows whether they even noticed or not.
Yeah. Well, and that's been a move amongst sort of, white hat, gray hat, sort of friendly, I guess, although amongst the unfriendly hackers too, of the joke is patch your stuff before somebody else patches it for you. And that goes with, if I'm even a bad guy, I'm gonna get access to your unpatched Exchange server on the internet, and then once I'm in, I'm gonna patch it so nobody else
can't get in.
Can come in and do that for me. But there was a case where the FBI kind of took that approach of, if you're not going to patch your critical stuff, we'll go ahead and use the vulnerability to apply the patch for the vulnerability. over the internet. Yeah, fun, fun
So
stuff.
I'm sorry. Keep
No,
going. I wasn't sure how many slides you have here. Continue.
well, a couple of in this space I have found as I've dug into it more recently as we've been doing work on vulnerability stuff, even stuff I would like to say as a practitioner, I knew about vaguely, but didn't know much about. And so in this space, there are a lot of acronyms to know, but I think most people are vaguely aware of the, CVEs. And so that's, um, any vulnerability that comes out, there's this process of getting, it ends up turning into a CVE number.
Ooh,
Sometimes they get funky names, but go
this is
ahead.
my this is my favorite part.
Yeah, go to town.
That's not true. Not all vulnerabilities get CVEs. There are a lot of vulnerabilities, and it's becoming increasingly common that there are vulnerabilities in software packages that don't get CVEs. Now, when you think of mainstream software packages, yes. But I'm going to give you an example, and this is something that and you can stop me if you're like, this is dumb, just cut
No,
me off.
go.
But so we are moving from, you and I are kind of old and gray dudes that have worked in IT a long time. And, when we think of the programming language that we used to write in there, it's called imperative programming. The new programming language is like when we think about writing in React or Python, which is not new, but it's a declarative programming language. It's very different. And are you familiar with the differences between those two, or should I? Okay. So I'm going to just touch on it a little bit. So the example that I use is, a declarative, programming language is like if you bring me your car and say, fix my car. Like you don't really care how I do it as long as it works when you get it back. Imperative is like, please change the brakes on my car and do it this way. Okay. And one of the reasons we're able to develop software so quickly inside of especially microservices in the cloud is because we use declarative programming languages. And so that means we're calling all kinds of third-party packages into our software to make this cool graph or to do this login. And a lot of those packages are, some of them are pet projects. It could be somebody's capstone project from their master's thesis that they posted on GitHub. That's some script that makes some cool graph that's being called into a piece of software. That thing, that script, if it's got an issue with it, it's never going to get a CVE on it. And it, yes, probably is part of a production web app somewhere that someone's using. And so there are, when you think of major software, like, yes, your Cisco router is going to get a CVE, Red Hat's going to get a CVE, something with Oracle is going to get a CVE. But as the use of declarative programming languages increase, the percentage of vulnerabilities that get a CVE is actually decreasing.
Interesting. Well, and how does that relate to? There's a concept of exposures aren't vulnerabilities is another thing. So like misconfiguration, there's a whole set of things like
using a default username and password is never going to get a
yeah.
CVE on it.
Well, there's even once upon a time I worked on a team where we discovered like, hey, there's this configuration of a piece of Cisco software that it's not well understood, but if you leave it configured in the default configuration, you can you can have no security access to a machine, but you could, as system, you could run some scripts. And as we dug into it, it's like, yes, that's a feature of, don't configure, that is the default, but don't configure it that way. Basically was sort of the, so no CVE ever existed for that. It's just don't configure it that way.
I think maybe our point is, if I can summarize it, that as much as we'd like to feel like this warm and cozy blanket of CVEs around us, and like if we go patch all which is impossible anyways, but
Yeah.
if we went and I patched all known CVEs, that I would be completely like I'm as secure as I can be, and that's not true.
Yeah. No, I would, and even just for them from that secure configuration standpoint, patching CVEs isn't configuring security
Right.
particularly. You can have a fully patched system that has, in the case of a Windows box, has the SMB1 protocol turned on, and that's just, you've misconfigured it basically.
Yep.
The other interesting thing in this CVE space, and you pointed this out to me, the amount of time it takes before, like, those numbers are handed out in bulk way before the details of, well, what is the CVE? And like, if you're waiting, and you may not think you're actively waiting, but you have some piece of software that ties into this whole ecosystem, it can be days, weeks, months before a known security vulnerability, before it flows through this whole process of the CNA, the organization like Cisco or Microsoft or whoever, Apache Foundation, who's responsible for, some researcher identifies the issue, they submit it to Microsoft. Microsoft reserves, well, this is the pre-reserved number we're going to use for that one. People may even have workarounds and may even have, patches ready, but that whole CVE it could be days, weeks, months before it flows through the CVE system.
Yeah, so the CNAs, the numbering authority, and their pre-allocated blocks of CVEs that they can use. There's 100-ish CNAs out there, and MITRE and the NVD can issue CVEs directly too. But there's this tack time between when a CNA issues a CVE and when that CVE has defined details inside of the NVD. And the details we're going to see in the NVD is kind of a description of what the CVE is, but it's also going to tell us CPE, what packages apply, like how many Windows 10 images and versions apply to this kind of thing. And so I'll let you get into your diagram in just a second. But what we see right now is we track the tack time, that mean time to NVD of when someone announces a CVE and when we're able to pull the details from the NVD. And the average is 28 days right now.
Right.
Now, when we have high severity CVEs, like what we experienced with Log4j or some others recently, it's more like 3 or 4 days. But then you got to ask yourself, well, how does the average get to 28 days then? And that's because there's hundreds or thousands of lower criticality CVEs that can take up to 70 days to make it from a CNA into the NVD.
Right. And all of this is important because the solutions, the things people buy on the right that scan for or patch or deal with all of this stuff, those individual vendors can sort of jump over the normal process and like, this is a hot one. All our customers are asking about it. So just because of the focus, we'll go develop our own solution for finding that or for fixing that. But which is great for those ones that get a lot of attention, but for ones that get a little less attention, and probably the norm is that it flows through this whole CVE, CVSS score, which I want to talk about in a second here, and then flows into that NVD, which tells us, okay, which products does this apply to? How do you what are the fixed details and all that stuff?
And there's some really good security vendors that have teams who have their own intelligence feeds to figure out what CVEs are there and some do better than others at ingesting those early and being able to detect them. And some, I'll be honest, some of these that you have listed here don't have their own Intel feeds, and their scanning ability, if you made a Venn diagram, the NVD and the vulnerabilities they scan for are a
Or one and the
1-to-1
same.
match.
Yeah.
Yep. They don't have outside Intel feeds that they
Right.
use. And you still pay a bunch of money for it, which is kind of, it's not great.
Interesting. I think the other thing I would point out, like, I included this chart not just to be super instructive, but to point out just the basics of this is really messy. Like, if we imagine that there's some really logical rhyme or reason and consistency behind the scenes, like, where do they all come from?
Mhm.
There's this weird path from bad thing occurs to I can scan for it and I can patch for it. It's just very
When you dig into the details, it does not build confidence.
no,
Let's put it that way.
it's a little
You do,
gross.
the further you get in, the less confident you are that this is
Really,
working.
how does this work?
Just trust me. Yeah.
How does this ever work? Yeah, so it's interesting stuff. So CVSS, this I also wanted to talk a little bit because, again, as people mature and they go from, I don't know, I just patch stuff, I get more, okay, well, I know which stuff I'm patching and I know what to pay attention to. Then there comes a point where you get good enough at this, in my experience in organizations, that you overwhelm your capabilities. Your database administrators and your network team come back and say, I could spend all day, every day, just applying patches and never do any other work. You're going to have to tell me, or I'm not going to work every weekend because a high severity patch came out. Like, you need to tell me which things are drop dead, go do it now, and which things can wait 30 days or wait until the next cycle when I bundle them up and apply a bunch of them, that sort of thing. And the industry standard for that of, well, how important is this CVSS, Common Vulnerability Scoring System. There have been a number of versions of the CVSS.
And I think version 4, because we have so many 9s and 10s that come out, I think there are just 7 of them today.
Yeah.
I think how we're going to solve that in 4.0 is that we just add an 11 to the scale.
Turn it up to 11 and break off the knob. Yeah.
Yeah.
Well, what I was going to say about this one is this is the kind of thing that Aaron Shaver should just absolutely love, because there's a bunch of math that goes into CVSS, and going from 2 to 3, there's even more subcomponents in math. There's well, how exploitable is this? Is it hard to exploit? If I get it, how bad is the impact on that system? Is it, remote code execution, or is it, privilege-esque, or, data exfiltrate? What's the bad thing that I can do with it? And then the temporal and environmental metrics, okay, this is bad on an individual system, but we're just not seeing a lot of that going on right now out in the world. Or, nobody actually has that product, or there's an easy workaround. There are these other things that factor into it. And so you should love CVSS. Do you love CVSS?
I don't hate it, but I don't love it either. Because it's a little bit we've taken a fair, and again, I don't, I feel bad because I feel like I'm criticizing the people that are trying to solve this problem. And it's really a hard problem because they're trying to bring order to chaos. Really, I think is the best way to think of it. And I love, I've attempted this many times in my life of, if we could just, solve the problem of entropy inside of the system, then it would all work out fine.
Right.
Without honoring the fact that there's always going to be chaos there.
Yeah.
And I think this is some flawed logic on the fact that that you can structure the data in such a way that you're going to solve for all of that. And I'll give you some examples of, there's all kinds of high criticality that comes out, and there's things that this doesn't represent, like, do you have this system? First of all, right? Like,
Yeah.
and all what we see is a lot is people are like, a 10.0 came out, folks. Every hands on, all hands on deck. And then what they're finding is they're like, well, we don't use this. And
Yeah.
this was, well, thanks for wasting our time, everybody.
Yeah. Or
it's
yeah,
on a system that's not critical to our business.
correct. Yeah.
When you have
on that training system that has no data that, or, it's like market
when you have some
reporting.
medium or high vulnerability that's like, well, this is on all of our SAP web servers and we have 50 of them. Right. So somebody should fix that. So it lacks the the context.
Yeah. Well, and that's the reality. People who get to this level, they contemplate doing this, they implement it, and then they end up realizing, from what I've seen in organizations I've worked in, like, we start with the CVSS, and then we have to have our own, like, my CVS. Like, you have to start with that and say, well, this is the inherent score, but we're dialing it up or down. Like, you end up applying your own sort of high, medium, and low in your organization. And it's sort of like, well, I look at the highs and criticals, hopefully, when they come out, but then I got to do my own assessment of, well, how bad is that in my own organization? There's also, to me, there's what I was driving at, as well as there's this recent research that came out that said, if you ran your patching program based on a quantity of Twitter mentions versus CVES.
You sound so old when you talk like that. Twitter mentions. Are you kidding me?
Twitter activity is a better driver of your patch program than CVSS. I think. Please. Go ahead.
We're past time, but can I tell a fun story about this?
Yeah, please do.
Okay,
and we'll finish with that,
and then we'll wrap up. So, you're right. There's great new research that says, because here's all this structured data set where we try to get to perfect, but then we're humans. And so one of the questions we ask is like, well, I respect Brian. What's important to Brian? What's important to our other, men and women we respect as security professionals? And we're able to harvest that data via Twitter impressions, Reddit impressions, Google searches, like all kinds of big data analytics. And there is new research out from Kenna, from Cisco, but that they did a good thing. I have to give them credit. That using impressions from social media about what's important is at least twice as effective as using the CVSS. And so I learned something else the other day, because this is crowdsourcing, right? Crowdsourcing vulnerability intelligence and prioritization. Did you know that Webster's dictionary was crowdsourced originally? It was one of the first crowdsourcing projects, and it was done by, not Webster's, the Oxford English Dictionary,
OED,
not Webster's, was crowdsourced because they were failing to catalog the English language. And so in order to accomplish it, people would find a word, write down the context in which they found it, and then they would mail it in. And the Oxford English Dictionary is the assemblage of hundreds of thousands of people emailing, they didn't have email. That was dumb. Right. Mailing these little cards of paper. But it's effectively that, where the collective intelligence of all the security professionals is better than boiling it down to this discrete math here.
None of us is as smart as all of us, or something along those lines. Yeah, I can see it. I'm just going to finish off with, put it up here. The implementation group 1 boils down to patch your stuff, turn on automated patching for operating systems and whatever software supports it. Like, just do that, figure out how to live with the consequences of that and, risks that it creates.
Figure out how to automate your failback, and then you won't worry about it as much.
I would say people are scared of this, and I would say the two, one is automate failback, and 2 is have a pilot group that the automation is applied to before it's applied to everybody. And that to me is the secret
Call
sauce.
Brian. He'll take you to school on automation.
Yeah. And then there's all this, you make it more complicated than that. And there's all this assessment or just get a good Twitter feed of,
just do that. Come on.
Yeah.
We're all kind of lazy. Just do the Twitter feed, admit social media has at least some minute value here.
There you go. Okay. That's our topic for today. Good to talk to you. Take
Peace,
care,
bro.
man. Yeah,
Goodbye.
bye.